This is AI Podcast. I'm Ethan, and today we're digging into a fresh paper from AAAI 2025 called Planning in the Dark.
Hey everyone, I'm Maya. Planning in the dark sounds dramatic. What's the one-line takeaway?
The authors show you can build plans without an expert babysitting the system. They generate lots of possible rule sets with a language model, automatically filter the good ones, hand those to a classical planner, and then pick the plan that best matches the original description.
So no expert in the loop fixing things by hand. Who did this work?
Led by Sukai Huang with near Lipovetzky at the University of Melbourne.
Nice, give me the problem in plain terms.
Picture giving an AI a paragraph that describes how a little world works, like a library or a dungeon. Past systems often asked a human expert to translate that paragraph into formal rules. The snag is that the translation is slow, subjective, and does not scale. The paper's question is, can we skip the expert and still get reliable plans?
And by plan, we mean a sequence of actions that actually solves a task in that little world, right?
Exactly. Think of a recipe with steps that must obey the kitchen's physics. If you get the rules wrong, your cake never bakes.
What went wrong with earlier approaches?
Two big things. First, asking a language model to spit out a plan directly is like asking someone to write directions from memory with no map. You get confident-sounding steps, but they may be inconsistent. Second, hybrid systems did better by using a formal planner, but they still leaned on a human expert to clean up the rules the model produced. That expert loop could take many iterations and became the bottleneck.
Okay, so how do they avoid the expert without throwing away reliability?
By embracing ambiguity instead of fighting it. They ask the language model to produce many candidate rulebooks, not just one. Then they run those rulebooks through a learned critic that checks whether the rules really match the original description. After that, a classical planner tries to solve the task under those rules. Finally, they rank the resulting plans by how semantically aligned they are with the text.
Many rulebooks feels like crowdsourcing interpretations. What is this learned critic?
It's a sentence encoder fine-tuned to judge whether a candidate rule, like an action's preconditions and effects, actually matches the plain English description. They also add a guardrail called conformal prediction. Think of it as a calibrated confidence check. If the critic isn't confident, the rule goes to the discard pile.
Conformal prediction sounds mathy. Can you give me a kitchen analogy?
Sure. Imagine you taste a sauce and you've trained your tongue to know what marinara should be within a certain tolerance. If the taste falls outside that tolerance, you do not serve it. Same here. The system only keeps rule candidates that fall within a calibrated confidence band.
And then a classical planner steps in. Which planner are we talking about?
A width-based best-first search planner. The important part is that it gives you search over the state space with guarantees about how actions compose, instead of trusting the language model to think several moves ahead on its own.
How do they decide which plan to present at the end?
For each candidate plan, they look at each action, map it back to the natural language description, and compute how well the pair fits. Sum that up, and you get a score. Plans that better match the description move to the top.
What did they test this on?
3 domains designed to be outside the usual training data comfort zone. One is a library-themed world where you move books and people. One is a Minecraft-like resource world. And one is a little dungeon puzzle. They wrote 2 kinds of descriptions for each domain. Detailed ones with technical wording, and casual ones written by non-experts to keep things ambiguous.
I like that they used non-expert wording. It mirrors real instructions in the wild. How does the language model generate diverse rulebooks? Just temperature cranked up?
They run multiple instances with diversity settings and slightly different prompts, so you get a variety of plausible interpretations. Think of asking 10 cooks to write what they think the house marinara recipe is. You will get variations.
And the critic with the confidence band filters that pile down. How much does it shrink?
A lot. After filtering, they kept only a tiny slice of the original candidate combinations, on the order of a few percent, and the fraction that actually led to solvable plans roughly doubled, from about 11% to around 23%.
So you prune most of the hay and end up with more needles. Sounds like a win.
Right. And when humans compared the top plans to a reference solution, the pipeline's plans were judged closer to the gold standard than a strong direct reasoning approach like tree of thought.
That is impressive. Was there a particular challenge case they highlighted?
The classic Sussman anomaly from planning. It is the kind of puzzle where the right solution interleaves sub-goals. Direct language model planning tends to stick to one sub-goal then the other and gets stuck. With a good rule set and a classical planner, interleaving emerges naturally, and the system found correct plans.
I want to zoom in on soundness. When you say the plans are sound, do we mean sound relative to the rules the model invented, or sound relative to the real world?
Great question. Sound relative to the rules the system kept. If the rulebook says doors can be opened only with a key, the planner will respect that. Whether the original text actually meant a magnetic badge is another matter. The paper is careful on this point. It reduces human bias but still relies on the critic to capture the intended meaning.
So the alignment score is a proxy for intent. It works well, but it is still a proxy.
Exactly. Another limitation is the small human studies. They used a handful of non-expert descriptions and a small panel for judging plan quality. That is reasonable for a first pass, but we should not overgeneralize.
What about compute and cost? Running many language model instances, a critic and a planner sounds, well, not free.
They did not foreground cost numbers. Conceptually, the filtering step pays for itself by slashing the search space, but we still want profiling to compare against an expert in the loop or against a single strong model.
Reproducibility?
They describe the prompts and components, and they note using an accessible open model for generation, plus off-the-shelf encoders they fine-tuned. Still, details like exact seeds, prompt phrasing, and conformal thresholds can change outcomes, so a public repo and scripts are important for faithful replication.
Let's ground this with a concrete example. Suppose I write a casual description like, in the dungeon you can push a crate to hold down a plate that opens a door if the torch is lit. How does the pipeline handle that?
One language model instance might propose a push action that requires the crate and the hero in the same cell and results in the crate moving. Another might forget the torch prerequisite. The critic compares each proposed rule to the sentence about torches and plates. The ones that miss the torch condition are flagged as low confidence and dropped. The planner then searches under the remaining rule books and finds a plan where you light the torch, push the crate onto the plate, and go through the door. The ranking step chooses the plan whose actions best match the wording you gave.
That helps. What do you think is the most important conceptual move in the paper?
Treating ambiguity as a resource. Instead of forcing the model to commit to one brittle interpretation, the system collects multiple interpretations, then uses learning and search to narrow to the versions that are both consistent with the text and solvable.
And what would you like to see next?
Better ways to measure the quality of rule sets themselves, not just whether a planner can solve tasks. Also larger, more varied domains like robotics or logistics, and a careful look at the cost and latency curves as you vary the number of model instances and the strictness of the confidence filter.
I would add a gentle human in the loop at the end. Not editing rules, just choosing among 2 or 3 candidate plans and saying which aligns with their intent. That keeps the expert burden low, but ties the system back to real user goals.
I like that. It turns the expert from a mechanic into a final check writer.
Before we wrap, give me the quick takeaway one more time.
Sure. Generate many possible rulebooks, learn to filter them with a calibrated critic, use a classical planner to search for solutions, and pick the plan that best matches the original description. In their tests, that pipeline solved more tasks than direct prompting and produced plans humans judged closer to a reference.
Right. And the caveats are that alignment is measured by proxy, human studies were small, and we still want solid cost numbers.
Exactly. But as a design pattern, it is compelling. Let the language model imagine, let the critic verify, let the planner search.
That is a crisp way to put it. Thanks, Ethan.
Thanks, Maya. This was AI Podcast. See you next time.